Let's graph f of x equals negative 2 log base 2 of negative x minus 6 minus 5. So come to the right over here. When you are given a problem that looks like this, I am going to need you to slightly rewrite it. So here's what I want you to do. Let's bring that negative 2 over and the log base 2. The negative x minus 6 quantity, I do need you to rewrite this quantity for me. I need you to rewrite it in factored form. So what I want you to do is I need you to factor out the negative, and then if I pull a negative off of negative x, it will become positive, and if I pull a negative out of negative 6, it's going to be positive. So what I'm asking you to do is undistribute the quantity that I highlighted in pink. Because if you notice, I'm not rewriting anything. I'm not changing the problem by any means, because if I redistribute the negative to x and plus 6, I will end up right back where I was with the original problem. So first step, merely just rewrite. Now let's just go ahead and jump into our transformations. The first transformation we look for is horizontal transformation. Horizontal transformation is found by looking to see if there's anything happening with regards to adding or subtracting values to your x. Right over here in your rewritten equation, we notice that our x is adding a 6. With horizontal transformations, you always do the opposite, okay? So in this case, plus 6 implies that you are going left 6 units, okay? Your entire graph is moving left 6 units. The next transformation on our list is there any multiplication going on? So what you do is you look to see, okay, well, right now I do see a coefficient of my logarithm happening, and the coefficient is a 2. It's a negative 2, but I'm going to look at just the 2 for a second. That is my vertical stretch, okay? Multiplication implies stretch or compression. In this case, I have a vertical stretch by a factor of 2. And you're probably asking, well, wait a second. Okay, that is my vertical stretch by a factor of 2, but what about that negative? What is happening with that negative? Well, that's a good question. That negative, which I'm going to highlight in green, is also playing a role, and that's actually our next transformation. That is a reflection. The graph is going to reflect over the x-axis. That's what negatives do. They cause reflection to happen. You are going to notice, though, that there is another negative happening here, and that negative, let us highlight it in blue. That negative I'm talking about is this one right over here. We do need to pay attention to that negative as well, okay? So you have 2 reflections for this transformation of reflection occurring. This one instead is not going to reflect over the x-axis, because notice that your negative is with the x, not in front of the entire function, okay? This instead is going to reflect over some vertical line. Reflection is happening over a vertical line, specifically our vertical asymptote. Our logarithmic graphs have vertical asymptotes. So this is what the reflection is going to be. The first reflection was over a horizontal, which is our x-axis, and the other negative is a reflection over our vertical asymptote. And then we ask ourselves, for the last transformation, is there any vertical transformations happening? And in this case, we do also have a vertical transformation happening, and that's this number right over here. Vertical translations happen when you see numbers adding or subtracting to your entire function. You do exactly what it says. You don't do the opposite like you did in horizontal. So here, you are going to go down 5 units with those points. Okay, they go down. So let's take this summary of transformations and show, using our table of values, what's happening to our 3 critical points. So we have an x and a y, and our y values are going to have the negative 1, 0, 1. If it was an exponential, you'll put it under the x. The reciprocal of our base is going to be a 1/2. So remember, the 2 is coming from, I'm going to circle it right here. That's where what you're using, okay? So you take the reciprocal of that number, and it's a 1/2. For my 0 y coordinate, my x is going to be a 1. And then for my 1 y coordinate, you are going to put the actual base. In this case, it was a 2. So that's the parent function critical points. These points moved left 6. So what happens, I'm actually going to shift this over a little bit so I can actually write it better. 1/2, 1, and 2. These x values are going to move left 6. So that means it affects my x coordinates, and left 6 means I need to subtract 6 from each one of those. So the results of that, I'm going to write it in my new table. So I'm going to go down below. 1/2 minus 6 would be negative 5.5. 1 minus 6 is a negative 5, and 2 minus 6 is a negative 4. Okay? Then the vertical stretch by a factor of 2 tells me that I am going to multiply by 2 to the y values. So if I multiply by 2 on each one of these, my values are going to become negative 2, 0, and positive 2. So notice, as of right now, I did the first bullet and I did the second bullet. Reflection over the x-axis. Well, what do you do there? Whenever you have reflection over the x-axis, all I need you to do is multiply your y values by negative 1, or you know what? I'm not even going to say that. Multiply your y values just implies that you change the signs of your y. Okay? So notice what's happening. Negative means negative 1, so I'm changing the sign. So my y value here, instead of negative 2, will become positive 2. 0 times negative 1 stays, and 2 becomes negative 2. So now you have 2, 0, 2. Some students say, Ms. Hanlon, can I just put both of these together? You can. Vertical stretch, a factor of 2 is a 2, so you multiply it by 2. Reflection means multiply by negative 1. So if you want to combine these and just multiply everything by negative 2, you would have ended up with these same numbers. So it's up to you, okay? So notice right here, if I had, I'm going to erase these positive 2's, and if I had just said, oh, multiply by negative 2, multiply by negative 2, and multiply by negative 2, notice that you're getting the answers below, okay? So you can combine those two steps. So I'm going to plot these points because the next step is, oh, let me put a check mark here. We're done with this step, is reflect over the vertical asymptote. So let's go ahead and write over here that we know that it's a vertical asymptote because it's a logarithm. And we know from our parent function knowledge that our asymptote is actually here at x equals 0. But because our graph has moved left 6, right over here, see, our graph has moved to left 6, that means this asymptote has to move in this direction, 6 units over. So actually, our asymptote is now right here. Okay, so you will drag that on your Delta Math program. And let's plot the points. Negative 5.5 comma 2, and negative 5, 0, and negative 4, negative 2. Now, the step that we're looking at right now is the blue step, and the blue step is telling us to reflect over the vertical asymptote. So what that is we are going to jump these points over. So you're going to go right here to the left, jump over to the left, and jump over to the left. Okay, so literally all you're doing is jumping over, but make sure that you keep the same distance away from your vertical asymptote every single time, okay? So that's the next step that you just finished doing, this blue step. And now you're down to the last step where it says move down 5 units. So all I'm going to do is literally these y values right here, I'm just subtracting by 5 because I'm going down 5 units. And you can physically just move your dots as well. But if you're mathematical, 2 minus 5, you're going to end up at -3, -5, and -7. So I'm moving down the first dot to -3. So let's make that dot, let's make it purple for Timber Creek. So this goes down to actually -3. And -3 is right here. Okay, so all I did was go down -3 units, okay? I mean -5 units, sorry. 1, 2, 3, 4, 5. I went down 5 blocks. The next one goes down to -5. So that that drops down 5 units. And then this one drops down to -7 right here. Okay, so I'm going to erase those black dots eventually. So notice how they all dropped 5 units down. 1, 2, 3. Did that go down right? Yeah, that's right. -4, -5. Hold on. This pink dot, maybe you caught it. This pink dot, I went to graphed it at -3 actually. It should be right here. -4, -2. And so this black dot, so sorry. So I move it over right here. There we go. Okay, so -4, -2, which was this right here. So sorry, I graphed it at -4, -3. So there's -4, -2, and now I'm reflecting it over to that side. And so now I can go down 5 units. 1, 2, 3, 4, 5. And so my purple, where's my purple? 1, 2, 3, 4, 5 is right here. Now it makes sense. -4, -7. Okay. And so now when you click graph, obviously it will graph this purple graph. Sorry for the confusion there. My chart was correct. I just had plotted it in the incorrect spot. Okay. And so if you maintain the order of your transformations and just do one thing at a time, you will complete all bulleted points. Again, this is the most difficult it will ever get. It really combined all the transformations into one problem, so I wanted to show you so that you have an idea of what to do mathematically on the table and how to move these graphs if you did end up having a reflection over vertical asymptote. So remember, it's going to require you having to rewrite the problem. If you end up with something like this, please remember, rewrite it. Okay? All right, good luck with all your graphing. Thanks for watching.